So what we're going to be doing for this week is talking about area, and I just want to give you a little review on area of parallelograms, triangles. We're not going to do compound figures, but we're going to do trapezoids, and we're going to pretty much do all of that in one day, and then later on we're going to get into surface area and volume. This will not be anything too difficult for you, and what it basically is you never got to learn this in 7th grade or probably in 6th grade. So if so, it's just a review. Find the area of a parallelogram. Well, before we do that, let's look at the area of a rectangle. We all know that, and hopefully you still have those gold sheets and some of that information is on there. But if I remember right, all of you remembered that that was length times width. You can also write area as base times height. So here's my length, here's my width, plug it in. Area is equal to 15 times 35. Multiply that out on your calculator, and we get 525. Now remember, area is always units squared. Okay, so for instance here, it's going to be centimeters squared. You can also write this as 525 square centimeters. This is the more common way of doing it today. So that's a rectangle. A parallelogram is basically just a pushed over rectangle. So area of a parallelogram is you're going to take the base times the height. Now this height is an important concept, and you'll see this a lot in geometry. This height is the segment that is perpendicular. Hopefully you all know what perpendicular is. Perpendicular means that it forms a right angle, a line that intersects and forms a 90-degree angle. This little symbol right here, I'm going to show you that symbol again. This little symbol right here means, hey, I'm a right angle. So this is a right angle, but your height is the perpendicular distance from one point to that segment. So this is going to be your height, and look for those. That's going to be a big thing of what you do. So now if we look at parallelograms, we're just going to see that all you have to do is take the base times the height. So the base times the height. The base, now on this one, notice what happens. The base is right here. This is still your height. Why did they put it out there when they could have put it in there? I don't know. We don't decide that, but you're just going to multiply the two of them. Sometimes your height is on the side, but you always look to see what is it perpendicular to. Whatever it's perpendicular to, that's your base, and the segments that's perpendicular, that's your height. Okay, you can all multiply base times height. I don't need to go over that with you. Okay, let's try one. So area of this is going to be base times height. So that's 8 times 4.25. We're going to multiply that, and we get 34. And of course, it's area, so it's meters squared. Great. So now let's go to a triangle. Now a triangle is half the product of base and height. This should look very familiar to you also. And why that comes about, and this one can show it to you right here. Just look at number 1. If we were to complete this, oops, I wanted that to be pink. If we were to complete this out, whoops, you could see that this would be a rectangle. Well, if it was a rectangle, we'd just take base times height. But notice how it looks like it's just half of that rectangle? And there are proofs to show that and everything else, but I just wanted to physically show you why that's working. So to find the area of the triangle, I can take 1/2 base times height. And what this points out is that you can take base times height and then divide by 2. Okay? So to find the area of a triangle, my formula is 1/2 base times height. So I'm going to take 1/2. What's the base? 14. Oh, I forgot they did this to us right off the bat. That's okay, we're smart. And we have the height here. The area is 42. Okay, so we're going to solve. This kind of goes back to those literal equations we've had. We're going to solve for h. So I'm going to clean up the sides, and I get 1/2 of 14 is 7h. Just solve the equation, and we get 6 is equal to the height. And that's 6 meters, because it is just a height. It is not an area. Okay, now here, our right triangle, one is the base and one is the height. It doesn't matter which one's which. So again, it's going to be 1/2 base times height. So 1/2 times the base. Which one is base and which one is height? It doesn't matter. So 2 times 5 is 10. Half of 10 is 5 feet squared. Here my height is on the outside. Oh no, we have a fraction, but you guys have cool calculators that do fractions for you. Or you can change them to decimals, because we know this is 0.75 and this is 0.5. Okay? So down here, the only thing they do is they tell you the area and they give you a base, so you have to find the height. You just plug it into the formula. We did one of these earlier. So the area is given and the base is given. You have to find the height. You can solve that equation. You're good to go. Now here's your practice assignment, what you're going to be working on for homework, but we're going to go to the next one. So this one will be a homework page. Okay? And since I'm going to be absent today, you're going to do more than what you're going to do a few more. I'll change that out on Schoology. And there's more problems. We're not going to do all of these, but don't worry about it. Okay, now we get to the area of a trapezoid. Hopefully you all remember what a trapezoid looks like. A trapezoid, by definition, is two sides are parallel. Okay, it's a four-sided figure, so it's a quadrilateral in which two sides are parallel. Those are called your bases. Now, does it matter which one's base 1 and base 2? No. Here they show that the smaller one is base 1, but it doesn't have to be. Okay, so all this formula says is I'm going to take 1/2 times the height times the sum of the bases. Doesn't that look a lot like a triangle? Yeah, 1/2 base times height, but we have to add the bases, okay? And I'm sure there's cool videos out there to show why that works. So to find the area of a trapezoid, a lot of times it's easier if we write down that formula, so then we can just plug it in. Now, which one's base 1 and base 2? Again, it doesn't matter. What's my height? Well, there we go again. There's that perpendicular distance. That perpendicular segment is going to be your height. Now you're going to add your bases. So 1/2 of 4 is 2. 2 times 9 is 18. Didn't even need a calculator. Woohoo! Centimeters. And we're in area, so centimeters squared. Okay? So if you're in class right now, I'd have you pick one to see which one we would do. Let's do number 3. So area of a trapezoid, 1/2 height times base 1 plus base 2. So we get 1/2 times the height. Look at your height. Even though it's a height, it can lay on its side because the whole trapezoid is. So your height is 12. But notice it's that dashed line, but more importantly, it comes perpendicular to the base. It's actually perpendicular to both of the bases. It just only shows it with one. Okay? And then you're going to add your bases. Pull out the calculator. I'm going to simplify first. I know you can just plug it in, but it's old habit. And we get 198. And of course it's area, so it's inches squared. You get the idea, I believe. And then you're going to do some practice with trapezoids. Okay? You guys can do that. Let's see. So make sure you look out on Schoology to see the exact assignment. But there's some notes. I'm sure you can figure out what's happening, and these formulas are written down. I don't expect you to memorize these formulas for anything. Just make sure you know how to use them. Great. So please go to Schoology and look to see what you are supposed to do as far as the assignment for today. Thank you very much. And if you have questions, let me know.